A burning question: can we quench the sun with water? Have you ever looked up at the sun on a hot summer's day and wondered, what if we could just cool it down a bit? It's a thought that might cross your mind when the heat becomes unbearable, and the sun seems like an unrelenting force. The idea of quenching the sun with water might sound like a whimsical fantasy, but let's dive deeper into this intriguing question. It's a question that sparks curiosity, but the reality of the sun's power makes the idea seem almost laughable. The sun is not just a giant light bulb in the sky, it's a massive, fiery ball of gas that has been burning for billions of years. Its energy output is so immense that it powers the entire solar system, providing the light and warmth necessary for life on Earth. The sun, our very own star, is an immense ball of burning gas, a colossal furnace that dwarfs our planet in both size and energy output. To put it into perspective, the sun's diameter is about 109 times that of Earth, and it contains 99.86% of the total mass of the solar system. The core of the sun reaches temperatures of around 15 million degrees Celsius, where nuclear fusion occurs, converting hydrogen into helium and releasing an enormous amount of energy. Could we really, truly cool it down with something as simple as water? Imagine pouring a bucket of water on a blazing inferno. It might sizzle and evaporate instantly, but it wouldn't make a dent in the fire. Now scale that up to the sun's size and energy, and you can see why the idea seems far-fetched. The answer, as we delve into the science of the sun, is a resounding no. Water, composed of hydrogen and oxygen, would not only fail to cool the sun, but could potentially fuel it further. The hydrogen in water could actually contribute to the nuclear fusion process, adding more fuel to the sun's already immense fire. But the journey to understanding why reveals fascinating insights into the nature of stars, the power of nuclear fusion, and the delicate balance that keeps our solar system in harmony. Stars like the sun are born from clouds of gas and dust, and their life cycles are driven by the process of nuclear fusion. This process is what makes stars shine so brightly and emit such incredible amounts of energy. Join me as we explore the sun's awesome power and understand why attempting to cool it down with water would be like trying to extinguish a volcano with a garden hose. The sun's energy is a fundamental part of our existence, and its power is a reminder of the incredible forces at work in the universe. By studying the sun, we not only learn about our own star, but also gain insights into the workings of other stars and the cosmos as a whole. So while we can't quench the sun with water, we can certainly quench our thirst for knowledge by exploring its mysteries. The sun's furnace, a look at its incomprehensible heat. Before we can even contemplate cooling the sun, we must first grasp the sheer magnitude of its heat. The sun, our closest star, is a colossal ball of burning gases, primarily hydrogen and helium. Its heat is not just intense, it's almost beyond human comprehension. The sun's surface, where those dazzling flares dance and sunspots appear, simmers at a staggering 5,500 degrees Celsius, or 9,932 degrees Fahrenheit. These sunspots, which appear as dark patches, are actually cooler regions caused by magnetic activity, yet they are still incredibly hot. To put that in perspective, that's hot enough to vaporize most metals instantly. Imagine a piece of iron or steel. It would turn into vapor in mere moments if exposed to the sun's surface temperature. This is a heat so intense that it challenges our very understanding of thermal energy. But that's just the surface. The sun's heat doesn't stop there. It only gets more extreme as we delve deeper. Journey to the sun's core, and you'll encounter temperatures exceeding 15 million degrees Celsius or 27 million degrees Fahrenheit. This core is the heart of the sun, where the most intense reactions occur. This unimaginable heat is the product of nuclear fusion, the process where hydrogen atoms fuse to form helium, releasing colossal amounts of energy in the process. Nuclear fusion is the same process that powers hydrogen bombs, but on a scale that is almost beyond human comprehension. It's this energy that powers the sun and bathes our solar system in light and warmth. Without this continuous nuclear fusion, the sun would not shine, and life on Earth would be impossible. The energy produced in the core takes thousands of years to reach the surface, where it is finally emitted as sunlight. Scientists have spent centuries studying the sun, trying to understand its complex mechanisms. From ancient astronomers who first charted its movements to modern-day astrophysicists using advanced telescopes and satellites, our quest to comprehend the sun's heat has been relentless. This understanding has practical applications too. Solar energy, harnessed from the sun's rays, is becoming an increasingly vital part of our energy solutions. By converting sunlight into electricity, we can power our homes and industries, reducing our reliance on fossil fuels. Future space missions aim to get even closer to the sun, to study its outer layers and solar winds. These missions will help us predict solar storms that can affect satellites and power grids on Earth, furthering our understanding of this magnificent star. The sun's heat, while incomprehensible, is also a source of life and energy. It drives weather patterns, supports plant life through photosynthesis, and provides the warmth necessary for life to thrive on our planet. The sun, in all its fiery glory, is both a giver of life and a reminder of the immense power of the universe. As we continue to study and understand the sun, we gain not only scientific knowledge but also a deeper appreciation for the delicate balance that sustains life on Earth. The sun's incomprehensible heat is a testament to the wonders of the cosmos, a blazing beacon in the vast expanse of space. The sun's energy, a force we can barely fathom. The sun's energy output is nothing short of mind-boggling. Every second, our star releases more energy than humanity has consumed throughout its entire existence. Imagine the most powerful explosion you can conceive, then multiply that by 1 billion, and you might begin to scratch the surface of the sun's energy production. This energy doesn't just disappear into the void, it travels through space as radiation, reaching us on Earth as light and heat. It's this solar energy that drives our weather patterns, fuels photosynthesis in plants, and ultimately makes life on Earth possible. The sun's energy is the very foundation of our existence. Water's limits. Evaporation against the sun's might. The sun, a colossal ball of burning gases, emits an immense amount of energy every second. Its surface temperature reaches about 5,500 degrees Celsius, and its core is even hotter at around 15 million degrees Celsius. This intense heat and light are what make life on Earth possible, but they also present a formidable challenge when it comes to cooling down anything in its vicinity. Now let's introduce water into the equation. Water, a substance so familiar and essential to us, has unique properties that make it incredibly useful in a variety of contexts. From the water we drink to the water we use in industrial processes, its ability to absorb and transfer heat is unparalleled. Water, the lifeblood of our planet, is known for its ability to absorb heat. When sunlight hits the surface of a lake or ocean, the water absorbs this energy, warming up in the process. This absorbed heat is then distributed throughout the water body, helping to regulate the Earth's climate and support marine life. We use it to cool down on hot days, whether by taking a refreshing swim in a pool or by drinking a cold glass of water. This cooling effect is due to water's high specific heat capacity, which means it can absorb a lot of heat before its temperature rises significantly. To regulate our body temperature, our bodies rely on water to maintain a stable internal environment. When we sweat, the water on our skin absorbs heat from our bodies and evaporates, taking that heat away and cooling us down. And in countless industrial processes, factories and power plants use water to cool machinery and prevent overheating. This is because water can absorb and carry away large amounts of heat, making it an efficient coolant. But could water, even in unimaginable quantities, truly cool down the sun? The idea might seem intriguing at first, but the reality is far more complex. The sun's energy output is so vast that it dwarfs any amount of water we could ever hope to use. The answer lies in understanding the process of evaporation. Evaporation is a phase transition from liquid to gas that occurs when water molecules gain enough energy to break free from the liquid's surface. This process requires a significant amount of energy known as the latent heat of vaporization. When water absorbs enough heat, it transitions from a liquid to a gaseous state, becoming water vapor. This phase change is crucial for many natural and industrial processes as it allows for the transfer of heat from one place to another. This process requires energy, which is drawn from the surrounding environment, thus cooling it down. For example, when water evaporates from a hot surface, it absorbs heat from that surface, lowering its temperature. However, the sun's heat is so intense that any water we could conceivably hurl at it would evaporate long before it even came close. the sheer energy radiated by the sun would cause the water to vaporize almost instantaneously, dispersing into the vastness of space. Instead of cooling the sun, the water would simply add more fuel to the fire. The hydrogen and oxygen in the water would break apart and potentially feed the sun's nuclear fusion process, making it burn even hotter. Thus, while water is an excellent coolant on Earth, it stands no chance against the might of the sun.